3-2 and 3-3, solving one-step inequalities. The learning target is to solve one-step inequalities. The math term is equivalent inequalities. Inequalities that have the same set of solutions. Solving inequalities using addition or subtraction. Addition property of inequality. This property states that you can add the same number to both sides and the inequality will still be true. So it is similar to the addition property of equality, except instead of equal signs, we have inequality symbols. Our first example, solve and graph the solution. When solving inequalities, you treat them the same way that you treat equations. X minus 15 is greater than negative 12. As I go to solve this, I'm going to add 15 to both sides, which in this case is the addition property of inequality. And I end up with x is greater than 3. Again, it's the same as solving an equation, we just have the inequality sign. Now we will graph our solution, and we'll start by drawing a number line. Since our solution said that x is greater than 3, I'm going to start my number line at 3 and then list some numbers that are greater than 3. When graphing on the number line, since it is greater than and not greater than or equal to, I'm not including the 3, so I put that open circle and I draw my line to the right and put an arrowhead because that means it goes on forever. So even though my graph here only shows 3, 4, 5, 6, 7, it actually continues. And that circle tells me I'm not including 3, but I am including 3.1 and all decimals that come after 3. The check is a little bit different than an equation because we don't want to choose 3 when we're plugging it in there. Our answer stated that x was greater than 3. So instead of choosing 3, I want to choose a number that was bigger than 3. So 4 minus 15 greater than negative 12. So 4 minus 15 is negative 11. And now I have to look at this statement. Is negative 11 greater than negative 12? And since it is, I'll say yes. It checks. The subtraction property of inequality states that we can subtract the same number from both sides and the inequality will still be true. Okay, to solve this inequality, t plus 6 is greater than negative 4. I start by using the subtraction property of inequality, and I'm going to subtract 6 from both sides. That leaves me with the answer t is greater than negative 10. So for my graph, I draw my number line. T is greater than negative 10, so I can start with negative 10 and make my numbers get closer to 0. It's going to be an open circle again because we're not including negative 10. It's just going to be everything greater than negative 10. And I draw my arrow on the end and it's going to the right because it's everything greater than negative 10. Now when I check, I want to pick something greater than negative 10. Since 0 is greater than negative 10, I'm going to choose 0 this time. 0 plus 6 is greater than negative 4. 6 is greater than negative 4. Since that's true, yes, it checks. Solving inequalities using multiplication and division. The multiplication property of inequality states that you're multiplying the same number on both sides of the inequality. However, When dealing with inequalities, if you multiply both sides by a negative number, you need to remember to flip the inequality sign. So let's take a look at example 3. Okay, -3/4 x is greater than or equal to 3. Now we multiply both sides by the reciprocal. So we're multiplying both sides by 4 over -3, which is the same thing as -4/3. Since we're multiplying both sides by a negative, we have to flip the sign in the middle. So on the left here, we know we're just left with x. Instead of greater than, it becomes less than. And on the right-hand side, we have 3 times -4 is going to give me -12 over 3. So our final answer is x is less than -4. Okay, so as I said before, you must flip the sign when multiplying both sides by a negative. So we end up with x is less than or equal to -4 instead of greater than or equal to. So now we will draw our graph. We have -4, -5, -6, and -7. And unlike the last time, we're including the -4 because it says less than or equal to. So I'm going to color in my circle so that I know I'm including the -4, and my arrow goes to the left because it's less than -4. Now for our check, again, we don't want to pick -4, even though it says less than or equal to. That won't tell you if you have the less than or greater than part correct. I also would like to pick something that's going to divide by 4. That will make it easier for me to plug in and check. So I'm going to pick -8. So -3 over 4 times -8 is greater than or equal to 3. So when we multiply this, we get 24 over 4 is greater than or equal to 3. 6 is greater than or equal to 3. So yes, it checks. Division property of inequality. This property is very similar to the multiplication property of inequality. It states that dividing both sides by the same number will keep the inequality true. However, if you're dividing both sides by a negative, then you must flip the sign, just as we did in multiplication property of inequality. Okay, let's try example 4. -9y is less than or equal to 63. Now, just as if we were solving an equation, we're going to divide both sides by -9. But since I divided both sides by -9, I have to flip the sign in my answer. So y is greater than or equal to -7. Then we'll go to graph it. So we have -7, -6, -5, -4. It has greater than or equal to, so we're going to include -7. We color it in. We draw our arrow to the right. And there's our graph. Now when we go to check it, we want to pick a number that is greater than -7. So I'm going to pick 0. -9 times 0 is less than or equal to 63. -9 times 0 is 0. 0 is less than or equal to 63, so yes, it checks. Now, if I did not flip the sign, it wouldn't have worked because it would have said 0 is greater than 63, and that's not true. So we would have thought we made a mistake. So it's very important to do your checks to make sure that you're flipping the sign. So just as we stated with the multiplication property of inequality, you must flip the sign when dividing both sides by a negative. Writing and solving an inequality. The hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos to your hard drive. What are the possible sizes of the home video collection you can save? Just as any other word problems, we're going to start with listing the information that we were given. So the important information is the capacity is 120 gigabytes. 85 gigabytes were already used, and we need the size of the home video collection. So to define the variable, the size of the home video collection will be what x equals. Now, the capacity is 120 gigabytes. That means it's the most that the hard drive can hold. So if it's the most that the hard drive can hold, then that means whatever is on it has to be less than or equal to 120 gigabytes. Now there's already 85 gigabytes on there, and whatever size of the home video collection, those two added together will have to be less than or equal to 120 gigabytes. So now we go to solve. Minus 85 on both sides, and x is less than or equal to 35. Now the question was, what are the possible sizes of the home video collection that you could save? And it is less than or equal to 35 gigabytes is the possible sizes of the home video collection you could save. Now you do always have to think about your answer and make sure, does it make sense? And the word we use is it a viable solution? Okay, is it possible? In this case, yes. 35 gigabytes is a possible answer for the problem we are solving. We're going to do one more word problem. You walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? So let's list the important information. Okay, the important information here is that you earn $4.50 per dog, need to earn at least $75, and we're looking to find out how many dogs would you have to walk. So the number of dogs walked will be what our missing variable is. Okay, so again, we always look for that total. Well, we don't exactly have a total because we're dealing with inequalities, but you need to earn at least $75. Now that's a word you have to be careful with, because even though it's at least, it will be greater than, because you want at least $75, so $75 or more. So we'll start by putting greater than or equal to $75. And you earn $4.50 per dog, and x is the number of dogs, so we have $4.50 x. Okay, we can go about solving this just like a regular equation, except it's an inequality, so we do want to keep our inequality sign and not an equal sign. And when I divide, I get 16.6 repeating. X is greater than 16.6 repeating. Now, can you have 16.6 dogs? No, you can't. So that's where we want to talk about viable solutions. So in this case, viable solutions are you need to walk at least 17 dogs. So at least 17 dogs walked. Because if you only did 16, you wouldn't have that $75, so you'd have to round it up to 17 dogs in order for it to be a viable solution that answers the question. Now it is your turn to try these 5 examples. Do your best, try each problem. Make sure for the word problem you list the important information. It will help you solve the problem. Have a good night. See you tomorrow.